Uh, Good morning. Today we'll discuss two numerical examples involving free body diagram. Right? The first problem is there are two smooth spheres P and Q, each of radius 25 centimeter and weighing 500 Newton, resting in a horizontal channel having vertical walls. If the distance between the vertical walls is 90 centimeter, find the reactions at all points of contact. So this is the question. And if you were to solve this particular problem, so if you look at again, so there are now two spheres, P and Q. Suppose this sphere is P, so this is P, sphere P, and this is sphere Q, two spheres P and Q. So this is P, resting in a channel. So this is a channel which is perpendicular to the wall, and this is a cross section of it. Right? So two spheres P and Q is resting in a channel. You are told that the width of the channel is 90 centimeters. ഇതിന്റെ ഈ ഇവിടുന്ന് നിങ്ങളിങ്ങനെ ഇതിന്റെ ഒരു വിഡ്ത്ത് നോക്കുകയാണെങ്കിൽ this is 90 centimeters. Right? 90 centimeters. You are asked to find the reactions at all contact points. So which all are the contact points here? Right? If you consider the first sphere, let its center or center of gravity be here. I shall call it as O1. So suppose this is O1, the center of the first sphere. And suppose the center of the second sphere Q is here. It is O2. So these are the two centers. And which all are the contact points? So if you consider the sphere P, if you draw a horizontal line here, it meets the vertical wall at this point. So this is one contact point. I shall name it as A, first contact point. Okay. Now again, if you join the centers of these two circles, say O1 and O2, suppose you draw a line between O1 and O2 like this. Okay, I'll make it a chain line. Right, it meets at the two spheres meet at a point here. So that is the next contact point, which is B. I shall name it as B. Again, if you draw a horizontal line from O2, right, it meets the vertical wall here. So that is the next contact point, the third one, C. And finally, if you drop a perpendicular from O2 to the horizontal floor, it meets here. So this point here is the next contact point, D. So you're asked to find reactions at all these contact points. Means you're asked to find reactions at A, that will be RA. Right? Reaction at B, it will be RB. Reaction at C, RC, and reaction at D. So these are the four things that you need to find out. So this is our question. When you try to solve this problem, the first thing that you need to do is to find the angle that the line joining these two centers makes with the horizontal. That means if I draw a horizontal line here, I just draw a horizontal line here. This O1, O2 will make an angle with this horizontal line, say theta. So the first step is to find this angle theta. ഇതാണ് നമുക്ക് ആദ്യം കണ്ടുപിടിക്കേണ്ടത്. There is one reason for this, because O1 O2 will be the line of action of reaction at B. ഈ ആർ ബി എപ്പോഴും ആക്ട് ചെയ്യുന്നത് ഈ O1 O2ന്റെ ഡയറക്ഷനിലായിരിക്കും. അതുകൊണ്ട് we need to find this angle theta. തീറ്റ ഒരു ജോമെട്രി ഉപയോഗിച്ച് നമുക്ക് കണ്ടുപിടിക്കാം. അതിന് നമ്മൾ ചെയ്യേണ്ടത്, say you draw a, suppose you just extend this line and also draw a perpendicular from here. ഇങ്ങനെ ഒരു ട്രയാങ്കിൾ കൺസ്ട്രക്ട് ചെയ്യാം. So make it change line. Suppose this meets at some point here, say M. So this point is M. You can calculate this angle theta from this triangle O1 O2M. Okay, so I consider this right triangle. I'll mark here. You have a right triangle. Say you have a right triangle O1 O2 M. Right triangle ഉണ്ട്. If you consider this right triangle, right, you take the cosine of this angle theta. Say if you take cos theta will be adjacent side by hypotenuse. So adjacent side is O2M. Hypotenuse is O1 O2. So O2M by O1 O2. You know, you can find all these values of O2M and O1 O2. Say how much will be this O1 O2M? You know that the width of the channel is 90 centimeter. Right? So from this 90, if you can reduce O1A and O2C, you can get O2M. So instead of O2M, you can write it as 90 minus O1A minus O2C. So this is your numerator. And the denominator is O1 O2, that nothing but O1B, the radius of the first sphere, plus O2B, which is the radius of the sphere, second sphere cube. Now now it becomes more clear, no? So 90 minus, how much is O1A? It is 25, because the radius of the sphere is 25. O2C is also 25. So 90 minus 25 by minus 25. This O1 O2 is the sum of the two radii, so 25 plus 25. So you'll get it as, this will be, numerator will be 40, denominator by will be 50. From this you can calculate theta. Right? So theta is cos inverse 40 by 50. It will come around approximately 37 degrees. So that is that angle theta. It will come around just around 37 degrees. So you got this. So this is the first step that you should do when it comes to solving this particular problem. Now, the second step is to draw the free body diagram of sphere P. Right? So I just wanted to draw the free body diagram of sphere P. So I'll go to the next page. Right, I'll just do one thing. I'll just copy that figure here. I'll just take this figure. Okay, now I need to draw the free body diagram of sphere P. So I've drawn that sphere there. You should draw it, you should start from the sphere, you draw it in the exact size. And now you identify the various forces which are acting on the sphere P. Let's try that. Now, if you look at this figure, of course, the first thing is its weight, like the weight acting downwards. So you have the 500 Newton force which is acting downwards. ഇതാണ് ഒരു ഫോഴ്സ്. So that is 500 Newton. So you have 500 Newton force acting here. The other force is the reactions, right? So you have two reactions now. One is the reaction offered by the vertical wall. P vertical wall sphere P ne consider as a support. So it will offer a reaction here. This is the second force that will be denoted as RA. So reaction at A, which is RA. The third force is the reaction offered by sphere Q. If you consider sphere P, sphere Q is its support. So Q will be offering a reaction to sphere P along this line O1 O2. Like you have a reaction offered by sphere Q that is denoted as RB. So these are the three forces acting on the sphere P. Once you identify these forces, you can mark it on the free body diagram. Okay. So suppose we have the sphere here. Its center. Let's first mark the center of gravity. So suppose this is here, which is say O1. Right. One force. Let's mark all these forces. Let's start from the weight. So the weight will be acting downward, like vertically, and weight acting down. One force. Other force is the reaction at A. You have reaction at A acting at point A. And the third one is that RB, right? RB will be acting acting though RB. Right? Again, just take it out. So this will be RB. Okay. That will be. So I'll just mark all these forces. You have 500 Newton here. So this is 500 Newton. This force is RA. And this is RB, which is making an angle of 37 degrees with the horizontal. So this angle is 37 degrees. Right. So these are the three forces acting. Now, once you draw the free body diagram, next step is to write equations of equilibrium. Sigma fx equal to 0 and sigma fy equal to 0, and then solve those equations and find values for RA and RB. So that is the next step. So as I used to tell you, I shall just represent these forces in a Cartesian coordinate system. So I'll just draw X and a Cartesian coordinate system. Suppose you have I'll try to X and Y direction here. I'll try to draw the X and Y direction. Suppose this is your Y axis and this is your X axis. So I just mark those things. So you have your x and y direction. So this is x and this is y. I try to mark these forces. Okay. So you have the weight acting downwards. So if I draw it down, you have the weight acting downwards. You have RA acting to the left. Let me know. I'll draw to the left. To the left, you have RA. And then RB, which is inclined at an angle of 37 degrees to the horizontal. So these are the three forces which are acting. So this force is RB. So this is RB. Vertically downward is your 500 Newton. And to the left, you have RA. So once you do this, this will be easy for you to resolve and write equations of equilibrium. So this angle is 37 degrees now. And it's all acting at the point O1, which is the center of gravity of your sphere P. Now, once you represent all these forces, you can straight away write equations of equilibrium. So the first equation of equilibrium is sigma Fx equal to 0. Sigma F. I will write that equation. So here you have to resolve RB into x and y direction. So if I draw a perpendicular down, so you have one component here, which is RBX. I shall put it as RBX, which is nothing but RB cos 37, like cos 37. And if you resolve this RB in the y direction, you have one component here. So I'll put it as a RBY, which is RB sine 37. So you have two components. So if you consider the x component, you have in the positive direction, you have RB cos 37, the component of RB along x direction, 47, minus RA minus RA. So this here minus RA. This is equal to 0. You get equation number 1. Now we write sigma Fy equal to 0. The next equation, sigma Fx equal to 0. So in the positive y direction, you have RB sine 37 minus 500. So this is equal to 0. You get equation number 2. Now you need to solve these two equations and find values for RB and RA. So from equations 2, it's relatively simple. Equation 2, find that RB is given by 500 by sine 37. So this is one equation you get. So the value of RB will be 830.8 around. I'll note it here. 830.8 Newton. So that is RB. Substitute RB in equation 1. You can find RA. So RA is given by RB cos 37. So 830.8 into cos 37. So I got the value somewhere around 663.5 Newton. So that is R. So you got both RB and RA. So once you find RB and RA, you can move on to the next sphere, which is sphere Q. Draw the free body diagram of sphere Q. Okay. So here, when you try to come here and go for free body diagram of sphere Q, again we identify the various forces that are acting on sphere Q. So again, let's mark all these forces. The first force is, of course, its weight. Like the weight, it is acting downward from the center of gravity. Weight അടിയിലേക്ക് acting down. ഒരു force. Weight is 500 Newton. So I just mark it as 500 Newton. അതാണ് ഒരു force. So that is 500 Newton here. That is action. Now there are various reactions acting on this force. So as far as sphere Q is concerned, sphere P is a support. So P will be offering a reaction at B, which will be equivalent opposite to RB, which we already found out. But let's mark that. So you have a reaction acting here, just in the opposite direction of the previous RB. So you have RB here. So you can have RB. Okay, that is one of the reactions. Now you come here on this side at C. You have a this vertical wall will be a support to sphere Q. So you have a reaction at C. So that will be the third force. So you'll have a horizontal reaction acting at C. Horizontal reaction acting. So that will be the reaction acting at C. I'll mark it as RC. RC. And now the fourth one is the reaction offered by the horizontal floor. That will be reaction at D. So you will have one more reaction acting at D. That will be vertically up, opposite to 500 Newton. So that is that will be RD. So if you look at it, there are in fact 4 forces acting on this. We need to represent all these forces on the free body diagram. So I started with the sphere. I've drawn the sphere. Let's locate the center of gravity of it. Suppose its center of gravity is here. Shall mark it. Center of gravity is O2. Is O2, right? Now you have its weight acting downward. So if let's start from that action, that is the action involved. So you have the weight acting downward, vertically adileki, with force 500 Newton. I'll mark at the end. And of course you have RB, which is acting inclined to this leg. You have RB acting at point B. You have RB. Now you can have RC, which is horizontal. Horizontal line. You have RB acting here. Okay, and then finally you have RD, which is you will have RD. Okay, so we have marked all the four forces. 500 Newton acting downward. 500 Newton. Right? RB, which is England. RB. This is RC. And vertically up you have RD. RB will be making an angle of say 37 degrees with the horizontal or the x-axis. So this angle is 37 degrees. So these are the four forces acting on it. Now there are four forces. Again, come here, you identify these four forces, write equations of equilibrium, and then you can find values for RC and RT. Now, how will you do that? Again, I'll represent these forces in an XY plane. So I just draw a X and Y direction, do it here. I'll do a Y-axis, and suppose this is your X-axis. Okay. So I've drawn both X and Y directions. So this is X, and this is Y. Now the various forces acting. You have 500 Newton acting downward. You have your 500. So this point is O2. I'll mark all these points at the end. You have 500 Newton acting downward. You have RC in this direction. RD vertically up. RD. And then RB acting England. RB. Okay. I'll just extend it a little bit more so that you can resolve RB. I'll just extend this 500 Newton a little bit more. So you have another thing here. So if I write all these values, so this is 500 Newton, ideally acting. This is RC, horizontal. This is RD, vertically up. And this is RB. And it will be making an angle of 37 degrees with the horizontal. Okay. Next, what we need to do is write equations of equilibrium again. So you write sigma effect. Let's start with the resolving forces in the x direction. So I write sigma fx equal to 0. That is the first equation. So here you need to resolve this RB, right? RB is going to resolve. You have the x component of RB, which is RBX, which you got it as RB cos 37. Okay. Again, I'll resolve RB in the y direction also. So I'll have one component in this direction, which is RBY, which is RB sine 37. So you have two components. You can write fx equal to 0. Fx equal to 0 means positive direction is RC, like RC minus RB cos 37 equal to 0. So that is equation number 3. But we already know RB. Like RB, we already found out. RB is 830.8. So you can straight away find RC from this since we already know RB. So we'll get RC. RC is same as the RA, equally opposite ayathondo it will get it as 663.5. So that will be RC. Now you write sigma Fy equal to 0. Solve the forces in y direction. So you have start with the positive direction RD minus RB sine 37 minus 500 equal to 0. So that is equation number 4. You already know RB, so you can straight away write RD. RD is since there are two weights acting downwards and the walls are frictionless, you get around almost 1000 Newton, the sum of the two weights. So found all the reactions RA, you get RA, RB, RC, and R. Okay, so this is the this is how you solve it.